Hey, class. So today we're going to continue our discussion about significant figures by discussing the rules for multiplying and dividing numbers that have significant digits. So we're going to do a couple of practice problems here, and then you'll guys take the quiz again. But this is the most important one of these rule sets that we're going to talk about because almost all the time in chemistry, we're multiplying and dividing numbers that have significant figures or significant digits. So it's super important you guys learn these rules, because we're going to use them almost every day in this class from this point forward. So let's go ahead and get started with the first example. So again, I'm assuming you guys can do the math, and you can always use a calculator, so I'm not asking you to do this in your head or anything. So the answer is already on here. The question I have is, how many of these digits in my answer over here are still significant? How many of them can I actually keep in my answer, and how many of them were just made up by the calculator? Okay, so the rule for multiplying and dividing numbers with significant digits or significant figures is that you can only keep as many Sig Figs in your answer as the input that had the least Sig Figs. So this is different from adding and subtracting, because adding and subtracting was decimal places. We could keep the least decimal places. When you multiply and divide, you only get to keep the least Sig Figs. So this is where all those identifying sig fig rules you guys learned before are really going to come into play. So let's go through and look at our two inputs and figure out how many sig figs are in each. So in this first number here, remember, if it's not a zero, it's always significant. These two zeros here are sandwich zeros, so they're always significant. This is not a zero, so it's also significant. And then we have a trailing zero here, which is the tricky kind, and those are significant when there's a decimal point somewhere in the number, which there is. So this is also significant. So this number has 1, 2, 3, 4, 5 sig figs, okay? And our second number here, 2.1, doesn't have any zeros, so everything's significant. It has 2 sig figs. So what this means is that my answer can only have 2 significant figures, because I'm multiplying here, right? So again, when you multiply or divide, your answer can only keep as many sig figs as the fewest that you started with. So what that means, we're going to go over to the answer and go 2 sig figs over. So the first 2 is significant, the 1 is significant, and that's where we want to chop the number and round if we have to, okay? So that 0 does not round the 1 up at all, it just leaves it alone, and so the answer is going to be 2.1. And some of you guys are thinking, okay, I had something times 2.1 and my answer still stayed 2.1. Yes, absolutely it did, because that first number you started with, 1.0030, had some digits that were way down there past the decimal, and we just rounded them off because 2.1 only had 2 sig figs, okay? So sometimes in chemistry, not in math ever, but in chemistry, you can multiply a number times something else, and that number won't even change, even if it's not a 1, which is kind of crazy. So you tell your math teachers about sig figs, and they'll probably roll their eyes because they hear this every year. But the rules in math and chemistry are a little bit different than in regular math because we care about which digits actually mean something from a measurement. That's why we only get to keep 2 sig figs here. So the answer is 2.1. Let's look at one more problem. All right, so again, we are multiplying here. And the rule is, remember, we can only keep as many sig figs as the fewest we started with. So we have to go through our inputs and count the sig figs. So let's see how many sig figs are in this first number. Well, the 4 is always significant. These are 2 trailing zeros. So we check and see if there's a decimal. There is a decimal, so both of these are also significant. So this 4.00 has 3 sig figs. The next number, the zeros in front are leading zeros, and they're never significant, so we don't count them. But these 2 3s are not zeros, so they are significant. So this has 2 sig figs. So our answer can only keep the fewest sig figs. So our answer can only keep 2 sig figs. So that means we're going to go over here. And these 2 front zeros are not significant figures. They're leading zeros, so we don't care about those, okay? We're going to go 2 sig figs over. So that's my first sig fig, that's my second sig fig, and then round the number right there, okay? So that 2, again, does not round the 3 up. So my answer is going to be 0.013, right? So we got to keep 2 sig figs in our answer because that was the fewest that we started with. Okay, let's do another one. Here we go again. Okay, this time we're dividing, but it's the same rule. So all I need to do is go through my inputs and count the sig figs, right? So let's see, this first number, 9 is significant. 0, this 0 here is sandwich, and remember sandwich zeros are always significant. 8 significant. This time I have a trailing 0 here, but there's no decimal, so that 0 is not a sig fig. Now again, I'm not going to take it off the number. I'm just scratching through it to tell you it's not significant. So this first number only has 3 sig figs. The second number there has a significant 7, because it's not a 0, 2 sandwich zeros, because they're between the 7 and 9, so they're both significant. And finally, this 9 is also significant. So that number has 4 sig figs. And the rule is our answer can only keep as many sig figs as the fewest that we started with, which means we can only keep 3 sig figs in our answer. So we always count over from the left side of the number, and we count this many sig figs over and then round. Okay, so we're going to start from this 1. That's 1, 2, 3 sig figs. And now we're going to round the number at this point, right here between the 9 and the 5. So remember the rules for rounding is if it's a 5 or higher, it rounds the number up. So this 5 is going to round this 9 up. When 9 gets rounded up, of course, it turns into a 10, which means it's going to bump up to the next highest place on the number. So this is going to round to 130, right? But we have to tell the person reading our number that this number has 3 sig figs, okay? In other words, we have to tell them that this 0 in our number that we got now is significant. And how do we do that? How would we say this 0 means something and it's not just a guess? Well, it's a trailing 0, right? And how do we tell people trailing zeros are significant? We put a decimal on the number. So this 130 needs a little decimal point right here at the bottom to say that 0 is significant, okay? So now we have 3 sig figs in our answer, which is the same as the fewest we started with, and that's the correct number of sig figs. Congratulations! You guys have now learned all of the sig fig rules for the year. And I know this is new for you guys, and so I want you to have time to practice because it's, again, super important. We're going to use sig figs in every single calculation you do in this class. It's super important in chemistry because we want to make sure we're not lying in our answer. We don't want to have a bunch of digits in our answer that were not significant, that didn't come off of the instruments that we were using, okay? So just to recap this lesson today, the lights just went out. We'll keep going. When you multiply or divide numbers with sig figs, your answer can only keep as many sig figs as the fewest you started with, okay? So great job, guys. Go ahead and do the quiz, and then do some practice problems and make sure you get this down because, again, super important this year.